praise me today.
I know. He's trying.
I really don't feel comfortable with that. Those and all. I might report you.
All right, so what are the excluded values? So where do excluded values come from? X cannot be. How do I tell what X cannot be? Where do I look? The denominator. So when I look at the first fraction, it's obvious X cannot be 0 in the first fraction. Does everybody see that? 5 times what? Can't be 0. It can be 5 times anything, but it can't be 0. Are we paying attention? All right, how about the second fraction? X can't be what in the second fraction? 4 or negative 4. How about the last fraction? Well, I don't know, I have to factor it, right? So X can't be 4, I already have that one. So I'll add X can't be 1 to my list. And these are the excluded values. Those are the things that X cannot be. So if we were going to solve this equation, which we're not, if by chance we got any of those, we'd have to mark them out. Right? All right, let's look at the next one, B. What are the excluded values here? X can't be what? Negative 10. X can't be what? 2 or negative 2. Positive or negative 2. Does that 4, that 3x over 4, does that 4 have anything to do with excluded values? No. It can't be 0. It's 4. Only the x's in the denominator are going to give us excluded values. Are we good? All right, find all of the asymptotes. Now, I need to clarify something. I've not done a good job with this. You have vertical asymptotes. All right, let's just start with that. What does problem A have any vertical asymptotes? Well, I need to factor everything and kind of see. Well, it looks like it has 2, but it actually doesn't have 2 because it has a hole. And the question says vertical asymptotes. So this problem would have a vertical asymptote at x equals 1. And going forward, I'm going to be picky about this. Asymptotes are equations. So you have to say x equals 1, okay? Is everybody okay with that? It looks like it was going to have 2, but 1 canceled, so it only has 1. Okay? Now, the other asymptote is what we call an end behavior asymptote. And there are 2, I have it written wrong on the paper. The end behavior asymptotes are either horizontal or slant. So we want to know in this problem, are we going to have, instead of writing end behavior, I should write slant. Are we going to have a horizontal asymptote or are we going to have a slant asymptote? Horizontal. And it's going to be horizontal because these 2 powers match. And when they match, you have a horizontal asymptote and it's y equals x over x. Okay, these are both types of end behavior asymptotes. End behavior asymptotes will either be horizontal or they will be slant. You will not have both, one or the other. All right, so let's look at the next problem. do we have a vertical asymptote? In problem B, is there a vertical asymptote? B, x equals 2. Kids, if you got a denominator, you have a vertical asymptote. That is not going to cancel out. That's going to stay there. X equals 2 is your vertical asymptote. Now, will this one have a horizontal or a slant? It's going to be slant. How do I know? The top power is bigger. And how do I find the slant asymptote? I do the division. So there's my 3, my -4, and my 5. What am I putting in the box? 2. Do my division. And it looks like my slant asymptote, my end behavior asymptote. It's an end behavior asymptote. It happens to be slant. And it's y equals 3x plus 2. Got it? All right, let's look at the back side. Some of us are still struggling with this. So the picture is drawn. I didn't number these, and I should have. The first one says what happens as x approaches infinity. Where is infinity? All that way, right? So what happens as the curve goes that way? What is it doing? Well, it's getting bigger, but it's not getting bigger to infinity bigger. It's getting closer to 2. So that one is getting closer to 2. Right? All right, B, 2, second one. As x approaches 3, it's 0. It doesn't matter whether it's coming from the left or the right, because it's going to a point. Isn't the point 3, 0? So any limit is going to be 0. All right, how about the next one? X approaches 1 from the left. Positive infinity. As you come in from the left, isn't your pencil going up? Positive infinity. -2 from the right. -2 from the right. Positive infinity. That's going up also. It's parabola. The right side of -2 is going up. Negative infinity. What is happening as we go left? Still getting closer to 2, isn't it? How about -2 from the left? -2 from the left. Negative infinity? Right, Jimmy?
Yeah, I'm just tired.
Why is everyone so tired today?
I'm not tired.
We're doing about it.
I think
All right.
makes me tired.
What happens at 0? At 0, we just got a dot, don't we? A point, I mean. So what would the answer to that be? 3? Right? Got it? All right, number 4, we're going to solve some equations now. It isn't a bad idea to list your excluded values. What can A not be? -3 or -2. So I don't know what's going to happen, but we'll see if A is -3 or -2. How do we do this? Make all the denominators the same.
Plus side.
So they're all gonna have to have an a plus 3 and an a plus 2. Now be careful, this 1 is a fraction. And it's gonna have to have a plus 3, a plus 2 also. Every piece of the problem has to have the same denominator. So this one will need an a plus 2. So how are you? Are you okay at this point? Okay, now once all of the denominators are the same, I can disregard them and just look at my numerator. Now there's a lot of math to do, but none of it's hard. Use the FOIL, right? And the FOIL. Keep collecting the odd terms till we get FOIL. So a squared minus 4 minus a squared plus 5a plus 6. This can be a little bit tricky. Remember, that's a subtraction. So we are subtracting this whole thing.
Isn't it? We had some time
Wait, oh,
at the end.
where's the
Yeah,
number?
all the way at the end.
Yeah, thank you. It is a nice thing,
Well,
Jenny.
good job.
You may be tired, but you're on it. Thank
On
you.
it.
Minus 8 squared minus 5a minus 6. Oh, that worked out great. Negative 5a minus 10 equals 3a plus 9. Negative 8a equals 19. Round, or everybody, like, doing okay here?
Yeah.
So a equals negative 19/8, which is not one of my bad ones, so it's all good. That's the answer. All right. One more. I'm gonna factor that first denominator. So my common denominator is gonna be n squared n plus 5. Would you agree with that? So everything's gotta have an n squared and an n plus 5. So this is all good. This one needs an n squared. And this one needs an n plus 5. So 5 equals 4n squared plus n plus 5. Check that out, is that okay? So 4n squared plus n equals 0. What do I do with that? Factor out n. And it looks like n equals 0, or n equals negative 1/4. Probably 1 10 are going up, because what are my excluded values? easy it is to forget about that? N can't be zero, so your only answer is negative 1/4. Hmm? So we do not have a customer, is that correct? So Friday, we have some queasy poo. Okay? All right, good deal. Let's get our notes out. We're almost done. I've got a review sheet all ready to hand out. But we do have a couple more problems. 4 more is all we have left in our notes. Yeah. All right. Last time we were together, we did some work with inequalities. It was pretty easy, I think, mostly anyhow. Number 7 is not a hard problem, but it involves a little bit of work. I have to do some work. Okay? Now, we can certainly do that on our calculator, solve it graphically, but we're going to solve it algebraically. Does anybody have a thought on how we might start thinking about what our other inequalities all look like?
Subtract 4.
Yeah, good, good. We need to have a 0. Oh, we started this the other day, didn't we?
I think so. Yeah, this is as far as we got.
We need to have a 0. I was getting ready to get impressed, but we already talked about this. You gotta have a 0, okay? Now, I have 2 fractions being subtracted. Gotta get a common denominator. So the common denominator is just gonna be x minus 3. So I have x plus 1 minus 4x plus 12 all over x minus 3. If this had been an equals problem, then I could ignore my denominators. But in an inequality, both parts are essential, so I gotta keep my denominator. So my common denominator is x minus 3, and my total numerator is this, which I might as well go ahead and combine. Negative 3x plus 13. Good. So here's my number line, and my number line is going to have 2 dots on it. It's going to have a dot from the numerator, and it's going to have a dot from the denominator. The dot from the denominator is easy, x equals 3, right? Numerator's a little trickier, so when you're in doubt, just set it equal to 0 and solve it. And I got 13 thirds. So my denominator dot is a 3. I can eyeball that and tell. The numerator dot is at 13 thirds, which is like 4 1/3. So here's 3, and here's 13 thirds. Remember, they gotta be in order. That's a number line.
We have to make it so we draw a line between outside. Okay. Do you have to make it so we draw like in between the lines or
Well,
outside?
you gotta figure out where we're gonna shade.
Okay.
You gotta figure that out. It's either gonna be in between or it's gonna be outside. Out here or in between there. how can we tell real easily? Let's pick a number.
I think how many points?
Let's put 0 in. Put zeros out here. Let's put 0 in. What happens if you put in 0? If you put in 0, do you get a number less than 0?
Yeah, it's negative. Right there.
Wouldn't it be negative?
Yeah.
So that means that where 0 is on the number line is going to get colored in. Because when I put in 0, I got a negative number, which is what I wanted. This means negative. Since the problem doesn't have anything funky about it, there's no squaring, I know my shading's going to alternate. And when I say squaring, I mean I don't have a factor that looks like this. That messes it up. No, none of that's going on. So I know that if this is shaded, then so is this. And my answer is negative infinity to 3, 13 thirds to infinity. One of my other students very astutely said the other day we were doing something like this. So wait a minute, Mrs. Ford, I thought when it was a less than 0, it was always shaded in between. Do you remember that? Well, that's true. That's absolutely 100% true. The problem is this right here. When you put a negative out in front of your problem, what happens to that problem? It gets flipped. So if it was supposed to start up, it ends up starting down. So if it was supposed to be shaded in between, it ends up being shaded outside. That will always be true. Always. All right, one more, just like it. We have a 0. However, we do not have a common denominator. So this one will need an x minus 1. And this one will need an x plus 3. So one giant fraction, denominator is x plus 3x minus 1. And the numerator, 5x minus 5 plus 3x plus 9. Did I do my math right? So that makes, what, 8x plus 4? Dots. Yes, the wrong number one. How many dots? 3. 1 from the top, 2 from the bottom. This one's at negative 3. That one's at 1. Where's that one? Yep, negative 1/2. That's right. If you can't tell by looking at it, then you're going to set it equal to 0 and solve, and you get negative 1/2. So negative 3, negative 1/2, and 1 on my dots. I don't know where to shade. I know it's going to be every other section. I just don't know where to start. So let's pick a number. Any number that's not a dot. So what do you want to pick? 0. Zero's in here though this time. So I'm trying to figure out whether I'm going to shade that or not. So I put in 0. I get 4 over 3 times negative 1. that's a negative number. That's less than 0. So I'm gonna shade that section. So what else is shaded? Not that one. This one? So negative infinity, negative 3, negative 1/2. I thought maybe there'd be a math class to take care of that headache.
You think?
Always helps me. You okay? We have 2 more problems, guys. Hang in there. Now I'll give you a review sheet. Start going over some stuff. Here we go. Bring me your calculators. Get those calculators out. Fire them up. Number 9. We're going to design some boxes with a volume of at least 600. Squares are to be cut from the corners of a 20 by 25 piece of paper. You've done this before countless times. I really will do it on your semester plan. Four up the flaps, make an open box. What size should be cut from the cardboard? What size corner should be cut out? So what'd you say, Alden? Here you talking. What'd you say? 25 minus 2x. 20 minus 2x. And then it's x. That right there is the volume of the box, right? Length times width times height. Now we want the volume to be at least 600. So if we looked at this on our calculator, if we graph that volume equation, it's gonna look, it's a cube. I don't know what it's gonna look like, because it looks something like this, okay? And then we graph the line 600. If we want the volume to be more than 600, then aren't we concerned with this and this? Would you agree? But what's the domain of my problem? No, it's not all reals, because this piece of paper is not infinitely huge. What is the biggest that x can be? 10. And the smallest x can be is 0. So you are only going to be looking at the part of the graph from 0, I don't know, to wherever 10 is. I don't know what 10 is on the picture. But that's all you're going to be looking at. That's your domain. Okay? Actually, I'm going to make those parentheses. Because if x is 0, I don't even have a box. Okay? So, that is x min and max. Window. X min is 0, x max is 10. That's all I can look at. I need y max to be something bigger than 600. This is 600. Y max has to be bigger than that. Type in the equations. Monica, you need to be typing with us, sweetheart. How do you get rid of that? Now, I'm going to draw what I actually see. What I actually see is this. This is 10. This is 0. Remember, boys and look at more of the picture than that, but it will matter, then count, can't use it. This is the only part of the picture you can use. So that's X-min, that's X-max, that's gonna give you a mountain. And then cutting through the mountain is your line 600. And we want the volume, which is the mountain, to be bigger than 600. So isn't this my answer right here? So I'm gonna find those 2 points. Second calc intersect. And I got 1.659. And 6.159. So the question is, what size squares? Any squares between 1.659 actually are equal to, so we'll count those. 1.659 to 6.1. Any square in that interval will make the volume of your box 600 or more. Okay, is that bringing back fond memories? All right. Last problem in this whole packet. Oh my gosh. Do you know what's next? Chapter 3? Exponents and logarithms. Yes. Stuart's got to get tested first next week. Stuart Cannery will package tomato juice in 2-liter cylindrical cans. Find the radius and height of the cans if the cans have a surface area that is less than 1,000. Okay, so here's the deal. The company is making cans that have 2,000 cubic centimeters. They want to make these cans so that the surface area is less than 1,000. So the volume has to be 2,000. But we could have short squat cans, we could have big tall skinny cans. We just need the area to be less than 1,000. Anybody know how to find the area of a cylinder, the surface area of a cylinder?
No clue.
Oh, I can tell you.
I have a clue, but I need a refresher.
First of all,
There's 2 pi r squared.
let's say, what'd you say?
2 pi r squared.
It involves 2 pi r squared.
1/2 2 pi r.
Because this isn't exactly a cylinder, but use your imagination. The bottom and the top are both circles, and the area of a circle is pi r squared. So the surface area is 2 pi r squares. Now, plus some other stuff, but that's the top and the bottom.
Plus 2. Plus just the area plus 2
It's just the area of the rectangle, that's right. If you think about it, here's a cylinder, right? The sides of the cylinder are just a rectangle. You have the top and the bottom, but this is just a rectangle. The height of the rectangle is h. be careful. What's the, remember, it started out looking like this. What's the width of the rectangle? The circumference. And what's the formula for circumference?
2 pi r.
No.
2 r pi. I think that's it.
Why do you
It's
say
the-
no?
It's the
He's
diameter
asked.
of pi.
Yeah, so it's 2 pi r h. There it is. What? Okay, now, listen, Eli, you can't in your life, you can't possibly remember everything that you've been taught. It's impossible, unless you're one of those very special people. So what did we just do? We did not memorize that. We figured it out. That's what you gotta do. You gotta figure it out. Now, I need that surface area to be less than 1,000. Now, I'm gonna type this in on my calculator, but what's the problem? Can I type that in on my calculator?
Yes.
No. Why not? Can I type in two variables like that? No. So that's where this comes in. The volume, please pay attention. The volume of a cylinder is pi r squared h. The area of the base comes out. I know that has to be 2,000. So what does h have to be? 2,000 divided by pi r squared. And why is that useful? Because if I put that right here, then I can type it in on my calculator. Then I'll have 2 pi r squared plus 2 pi r 2,000 over pi r squared. I'll clean that up a little bit. 2 pi r squared plus what happens here? 4,000. Those are gonna cancel. One of those is gonna cancel over r. I think that's what I get. You figure that out and see if that's what you get. Kids in calculus class are always saying, how come they give me so much information? They gave you this extra information so that you could plug in an h and have just one variable instead of two. We're not using the volume. This is an area problem. But we needed that number to get rid of that h. Okay, let's type it in. Let's see what happens. Keep that x min at 0. You don't want, this can't be a negative number, so keep that at 0. Y max has to be at least bigger than 1,000. I got a good one. For my window, for the x's, I went from 0 to 15. For the y's, I went from 0 to 1,200. And I got a great picture.
I did not get
part right here, because I want my area to be less than 1,000. So I got an answer of everything between those. So 4.619 to 9.655. Those numbers match anything anybody else got?
Why the last one is it bracketed with these ones?
Because it wasn't equal to?
Okay, my numbers are slightly off, but I have 4.627.
No, it's not okay. Let me make sure I typed in the right equation.
That's what I got.
I think I messed something up.
I got that.
You got my numbers? Okay, yeah, so, no, Alden, they're gonna match exactly.
You're past after the third time. I know. It goes like after, it goes from this right and then this is supposed to be a pretty bad one. And then you go there all the way over to the first. So I'm gonna stand down.
Sydney?
Oh, sorry.
You have to go to the
All right, well, that takes care of those notes. Let me hand out a review sheet that is way too light. I just went through my folders and found these pages that I thought might be beneficial.
You are not. You better have a good one.
This was made in October 27th, 2004.
I didn't get a bad skin.
The math is not updated. What is?
You don't read the patch on it.
Ray just said the math be updated by now.
It's probably not. It's called post calculus. Use your soul.
You
it's
have
called
those.
ChatGPT. That's called
All right.
post calculus.
So let's, like, anything that looked like it might be usable, like copy. Why don't we don't have much time. Why don't we go ahead in preparation for our quiz? Let's do problem 2 on this page that says practice quiz 102714, the top page. Let's do problem number 2. Take a minute and see if you can fill in those limit statements, and then we'll check. 2.8, by the way, is due on Friday. Homework 2.8,
On Friday.
Friday. And today, Wednesday? Yeah, Friday.
Wait, what did you say, sorry?
It's 2.8 on Friday.
For what? Okay.
Hey, do you guys have these filled in yet?
Come on, boys.
Let's go.
Negative 1, negative 1, positive 1.
Negative one, negative one.
So maybe
Which is common.
figure out some more problems.
All right, who got an answer for the first one? The limit as we approach infinity is -1. That's your asymptote. How about negative infinity? Still -1. How about as you approach -3 from the left? Positive infinity.
Positive infinity.
How about as you approach 2 from the right? Positive infinity again? Maybe try that.
Like, I thought,
Limits are y values.
okay, that's what I was gonna,
Limits are
the
y
X is
values.
going
We know exactly what's happening with x. It tells me what's happening.
okay, that
Limits
makes
is what's happening.
Yeah, you
All right, number 3. Let's do it. We just did one today. I want to do another one. Number 3 is not on our quiz that we take next time, tomorrow. Huh? Friday?
What number?
Number 3. When we're done with this problem, I'll stop talking. Let's get this one
Come
done.
on, boys.
So what do we do first?
Subtract -2.
Subtract the 2. And remember that that 2 is a fraction. And since it's a fraction, I need to have a common denominator. So now, the 2 fractions will become 1 fraction. And the denominator of the 1 fraction will be x plus 2. And what will the numerator be? X minus 3 minus 2x minus 4. You're distributing -2. So negative x minus 7 over x plus 2, is that my fraction?
3/2.
And that has to be less than or equal to 0? All right, you figure out the answer and we'll compare notes. Quickly, let's take a minute, see if you can figure out the answer.
Oh, 3 in the half.
Yes.
But that little line under the plus sign.
Let's fill those bad boys in.
So those are dots are gonna have to be filled in, right?
I know my denominator dots can be at -2. The numerator one has a lot of negatives floating around, so I'm gonna go ahead and set it equal to 0 and solve it. And it looks like n is at -7. So -7 and -2 are my dots. And then I need to figure out where to shape. You can use the shortcut, and by the shortcut I mean when you have 2 dots, 2 distinct dots on the number line, and there's no squares, you don't have anything like this in the problem, then you're always going to shade either between them or outside of them. When it's a less than,
Yeah, that's right.
you're supposed to shade in between,
I think so.
but there's a negative hanging around in the front, so we're going to be shading outside. Now, for those of you that didn't understand the word I just said, pick a number, like 0 and plug it in. If I put in a 0, I get -7/2. Is that less than 0? Negative is less than 0. So I shade out here where 0 is.
Oh,
So if there wasn't a negative in front of it, since it's negative 7.2, it's 3.5, so you shade
So we're not supposed
3.5.
to shade what the answer is.
No, you shade less than.
This one.
So if that weren't there, less than you shade inside. These two numbers have nothing to do with it. They're not plotted.
Oh, okay.
And the ratio, they are individual.
Every day.
less than or equal to change anything about it?
What that changes is that this dot gets closed in. That one doesn't. Because the denominator cannot be 0. So x cannot be -2. It's an excluded value. So only the -7
I don't
is
get it, why?
included.
Put 0 at the top.
The denominator cannot be 0.
Denominator's
If you put a -2 in here, the denominator would be 0. So you can't put -2 there. You have an open dot at -2. Yeah. Yep. All right, so you got homework and a quiz next time I see you. And we'll continue our review. So do I see, wait, so I see you, I don't see you.
Friday.
So I see you Friday, Monday, Tuesday?
Yes, ma'am.
Or test me Tuesday. What? Today's a review of the 3 sections, seriously? That's Monday? Well, we'll see how Friday goes. We'll see how Friday goes.
I might come off on Friday if I'm not lazy.
You should just like not be lazy.
Thank you. But I already
Bye,
put
have a
some
great
time and
day.
effort into other things.
I don't think Army guys should be lazy. That's up to you.
Only protect and serve, you should not be lazy.
I didn't study the last test, but bam.
Especially when no building.
I will see you Friday. Of course you will. Why are you doing this?
I have to go out of town for a softball.
Of course.
Priorities, this is forward priorities.
And then you'll have to take a quiz.
I'm not actually getting late.
I think we Monday.
Thank you.
If that's how we do it. Paper dates.
All right. Have a good trip.
Thank you.
Don't forget to come back.